Today's math objective: solve one-step algebraic equations using the additive inverse or the multiplicative inverse. Let's begin. First of all, let's take a look at an equation, but as a picture. What you see here is a scale with 5 on both sides. Now symbolically, we'd see it written like this, as a numerical equation. 5 is the left expression, 5 is the right expression, and since they're an equal amount, we have an equal sign in the middle. The picture, we have a fulcrum. On the scale, we have 2 equal amounts, so it's balanced. Now, if we add 1 to the left side, it's no longer balanced. We have 6 on the left now, and it's no longer equal. So the left side is going to weigh down, and notice we have an unequal sign here, not equal. Now, in order to balance this out, we would need to add 1 more to the right. So let's do that right now. Now it's equal again. 6 is equal to 6. What we just did there is called algebra, because algebra literally means to complete by balancing. It's an old Arabic word, and that is the word that gives the subject its name. Algebra, to complete by balancing. Oh, here's a mathematician to help us out. What you do to one expression, you must do to the other. Keep the sides balanced. Thank you. So that was Muhammad al-Khwarizmi, and he is the father of algebra. And he used to play around with these types of equations all day long with numbers and variables, and as long as you keep your equations balanced, you're in business. Let's take a look at another one. We have 4 on the left, and we have a box on the right, and it's balanced. So let's write an algebraic equation using symbols to represent this picture. We're going to use an x to represent the unknown amount. Now on the other side we have 4, so we obviously know what's in the box. It's 4 because it's balanced. So this mystery amount, of course, is 4. Now what happens if we had something like this? We had 1, 2, 3, 4, 5, 6, 7, 8, 9 on the left. Remember, our fulcrum is our equal sign. 9 is equal to 3 plus whatever in this box. Here's how we would use it using symbols. So our goal here is to figure out what's in the box, or what is x. Now we're going to use the additive inverse. So what we're going to do is we're going to take these 3 away, but if we're going to take 3 away on the right, we better take 3 away on the left. This is called algebra. We take away 1, take away 2, take away 3, and then we have taken away 3, and we got the box all by itself. But it's no longer equal because we took away 3, so this side's heavier. So what should we do? Oh, here's Muhammad al-Khwarizmi again. What you do to one expression, you must do to the other. Keep the sides balanced. So let's get rid of this one, get rid of that one, get rid of that one. That gets rid of 3. And so now we've done the same to the left as we've done to the right. It's balanced again. Thank you. So x equals 6. And that's how you would solve an equation using symbols. Just get this x by itself. We added -3 to both expressions. This is called using the additive inverse. Oh yeah, so we learned earlier the additive inverse is simply adding the opposite of a term to get 0. And that's what we did. We had 3 over here. We added -3 and got rid of that 3. But we had to also add a -3 to the left. So 6 equals 6. Now let's use some symbols instead of just pictures now. Oh, Muhammad's going to be helping us out through this. Use the additive inverse. So what I'm going to do is I want to get x all by itself, in this case on the left side of the equal sign. To get this by itself, I have to get rid of the 5. So I'm going to add a -5. This is what Muhammad's calling the additive inverse. What you do to one side, you must do to the other. So notice on the right side, I'm also adding a -5. So on the left I have x, and on the right I have -8. I'm going to box in my solution. I can always check my work. I could put -8, substituting for my original x, and 5 plus a -8 indeed is -3. So that does work out. And that's how you use the additive inverse to solve an algebraic equation. Let's try one more. But this time we're going to use the multiplicative inverse. Now notice this picture. This is one full box, I don't even have a full box on the right side. What do I have? Yeah, I have a half of a box. So I have half of an x equals 4. This is a lot different than a half plus x. I don't even have a full x. But our goal in algebraic equations when I solve them is to get one x on one side of the equal sign, because what's on the other side is the value of that x. Oh, here comes Muhammad al-Khwarizmi creeping in again. Our goal is to find out how much would be in one box. Multiply both expressions by the multiplicative inverse. That's right, so if we multiply by the multiplicative inverse, that's the same as multiplying by the reciprocal. So, look what I'm going to do here. The reciprocal of 1/2 is 2 over 1, or 2. And I'm going to multiply 2 times 1/2. Multiply 1/2 x by 2, and I get 1x. See, I got 1x now. Any operation done to one expression must be done to the other. So if I multiply the right by 2, I got to multiply the left by 2. And 2 times 4, as we see, is 8. So 8 is equal to x. And that is our final solution. Once we have 1x alone on one side of the equal sign, the other side is the solution. Thank you. Now let's use just symbols. Muhammad again is going to be holding our hand as we walk through this. Use the multiplicative inverse. So I have 3/4 x. I don't even have a full x. I want to have a full x over here. So I'm going to multiply by 4 over 3. And 4/3 times 3/4 equals 1x. But notice, what I do to the left, I also did to the right. I multiply both sides by 4/3. What's Muhammad saying over there? Cross simplify when you multiply. So that's right, I can cross simplify here. This 4 and this 4 share a factor of 4, so those turn into 1s. And that way I could also cross simplify those 3s, and those turn into 1s. There's my 1x. I do the same thing here. This is really 3 over 1, so I cross simplify with those. I get -1 and then 1. And I get -1 times 4 is -4. A box in our solution, and we're done. So we solved this equation by using the multiplicative inverse. Now let's do one more. But this time I don't have a fraction as a coefficient in front of x. I just have an integer. We can actually take a shortcut. When the coefficient is an integer, just divide both sides by it. That's right. So think of it this way. I have -4 times x. And how do we undo the multiplication? With division. So I divide by the coefficient itself. But what I do to the right expression, I must do to the left expression. And as Muhammad al-Khwarizmi is saying, any value divided by itself is equal to 1. So I get 1x over here on the right. And 20 divided by -4 is -5. So I'm going to box in my solution and I'm done. So that is how you would solve a one-step algebraic equation using the additive inverse or the multiplicative inverse.